For thousands of years, humanity has accepted a single brutal truth. We are born, we age, and eventually we die. It is the one absolute certainty of our existence. But what if I told you that in 2026, that certainty is beginning to crack? What if aging isn't a natural law like gravity, but a software error that we finally learned how to debug? Right now, as you watch this video, there are people walking among us who may never experience old age in the way your grandparents did. We aren't talking about eating more kale or getting your 10,000 steps in. We are talking about a fundamental shift in our understanding of biology. A shift driven by artificial intelligence that is designing proteins nature never evolved, and by a radical new therapy that literally reboots your cells to a youthful state. The first human trials for this technology have already been greenlit by the FDA. It sounds like science fiction, but the documents and the data are real. We are standing on the precipice of the most significant moment in human history, the moment we decided that death might just be an option. But there is a dark side to this revolution, a side filled with failed experiments, dangerous side effects, and a looming societal divide that could split the human race in two. So before you get too excited about living forever, you need to understand what is actually happening in the secret labs of Silicon Valley right now, because the race to immortality has officially begun, and not everyone is going to make it to the finish line.
To understand how we fix aging, we first have to understand what it actually is. For decades, we thought the body was like a car. Parts wear out, tires go bald, and eventually the engine just stops running. This is the wear and tear theory, and for a long time it made perfect sense. But recent breakthroughs have turned that idea upside down. Leading researchers now believe that aging is actually a loss of information. Imagine your DNA is a compact disc or a pristine vinyl record. The music is your genetic code, and it contains the instructions for a perfect, youthful body. When you are young, the laser reads that music perfectly. Your skin is smooth, your eyes are sharp, and your energy is boundless. But as time goes on, that disc gets scratched. UV rays, bad food, stress, and environmental toxins all leave their mark on the surface. The music is still there. Your original DNA hasn't changed, but the scratches prevent the laser from reading the songs correctly. This is what scientists call epigenetic noise. The cells in your body forget their identity. A skin cell forgets it's supposed to be a skin cell and starts acting confused and dysfunctional. This confusion is what we see as wrinkles, gray hair, and organ failure. But here is the game-changing realization. If the music is still there under the scratches, we don't need to buy a new CD, we just need to polish the scratches away. This is the foundation of the information theory of aging, and it suggests that we can hit a reset button that restores the original operating system. It sounds incredible, but we have already done it in animals. We have taken old, blind mice and restored their vision completely by rebooting their optic nerves. We have taken human skin cells in a petri dish and turned back their biological clock by decades. The question is no longer, is it possible? The question is, can we do it in a whole human body without causing massive collateral damage? Because as we're about to see, rebooting a complex machine like a human is a lot more dangerous than rebooting a laptop.
This is where things get really crazy. For most of history, biological discovery moved at a snail's pace. Scientists would pipette liquids by hand, wait for cells to grow, and hope for a lucky break. But in the last few years, artificial intelligence has kicked the door down. You have probably heard of ChatGPT, but you might not know about its biological cousins. In early 2025, researchers unveiled models like GPT-4b Micro. These aren't trained on poetry or coding tutorials. They're trained on the fundamental language of life. They analyze protein sequences and 3D structures with a speed that the human mind cannot comprehend. Evolution took billions of years to design the proteins in your body. It did a good enough job to get you to reproductive age, but evolution doesn't care if you live to be 100. It only cares that you survive long enough to have kids. AI doesn't have that limitation. It can design proteins that are optimized for longevity, not just reproduction. Take the Yamanaka factors, for example. These are 4 specific proteins that can turn an adult cell back into a stem cell. They're the key to the reboot process I mentioned earlier. But the natural versions of these proteins aren't very efficient. Recently, AI models were used to redesign them. The result was synthetic proteins that are 50 times more effective at reprogramming cells than anything found in nature. Think about that for a second. We're improving on billions of years of evolution in a matter of months. This capability has compressed decades of research into a time frame we can actually witness. Companies like Retro Biosciences are using these tools right now. They're running simulations that would take thousands of years in a wet lab and finishing them over a lunch break. This is why the timeline for anti-aging tech has suddenly accelerated. We aren't just stumbling around in the dark anymore. We have a super intelligent flashlight guiding us exactly where we need to go. But even with AI guidance, biology is messy and unpredictable. And as we saw with some recent high-profile failures, computer models don't always match reality.
It is easy to get swept up in the excitement. Billionaires are tweeting about their protocols, and influencers are selling miracle supplements. But we need to pump the brakes and look at what has actually happened in the last 2 years. The field of longevity is currently navigating what experts call the trough of disillusionment. Take rapamycin, for example. For years, this drug was hailed as the most promising anti-aging compound we had. It worked wonders in mice, extending their lives significantly. Biohackers and tech moguls jumped on the bandwagon, taking it off-label in hopes of living forever. But by late 2024 and early 2025, the narrative started to crumble. High-profile figures publicly abandoned the drug. Why? Because they found it wasn't working for them. In some cases, it caused infections, spiked their blood sugar, and paradoxically accelerated their biological aging markers. It turns out that humans are not just big mice. Our biology is far more complex, and what helps a rodent live a few extra months might actually harm a human being. Then there was the taurine hype. A few years ago, everyone was convinced that taurine supplements were the secret elixir of life. But a major NIH study published in June 2025 threw a bucket of cold water on that fire. They found that taurine levels don't consistently decline with age in humans. In fact, in some cases, they actually go up. This doesn't mean these compounds are useless, but it proves that there is no magic pill. You cannot simply pop a supplement and expect to reverse the aging process. The biology of aging is a complex web of metabolic pathways, genetic damage, and cellular waste. Pulling one lever often breaks something else. This is why the serious money has moved away from supplements and toward something much more radical. We are done trying to patch the tire. We are now trying to replace the entire car. And that brings us to the most significant regulatory shift we have ever seen.
For decades, the FDA has held a firm position. Aging is not a disease. Therefore, you cannot treat it. You can treat cancer, heart disease, or Alzheimer's, but you cannot treat the underlying process of aging itself. This made it nearly impossible to get real longevity drugs approved. But the pressure has been building. In September 2025, we saw the first crack in the dam.
The FDA reversed a controversial ban on NMN, a popular molecule used to boost cellular energy. After a massive legal battle, they acknowledged its status as a lawful supplement. This was a huge win for the industry, but it was just the appetizer. The main course arrived in January 2026. That was when the FDA cleared an investigational new drug application for a company called Life Biosciences. This is a historic milestone. For the first time, regulators have allowed a therapy specifically designed to reverse cellular age into human trials. The therapy, known as ER100, targets a condition called optic neuropathy. But don't let the specific disease fool you. The mechanism of action is partial epigenetic reprogramming. They are using those Yamanaka factors to reboot the cells in the eye. If this trial is successful, it proves that we can safely reverse the age of human tissue. And once that door is opened, it cannot be closed. If we can rejuvenate the eye, why not the liver? Why not the heart? Why not the brain? This regulatory shift signals that the government is finally catching up to the science. They realize that the silver tsunami is coming. By 2050, a massive chunk of the population will be over the age of 65. If we don't find a way to keep those people healthy, our healthcare systems will collapse. So the government has a vested interest in making sure this technology works. But as we move from supplements to genetic engineering, the risks get exponentially higher. We aren't just risking an upset stomach anymore. We are risking something far more terrifying.
Here is the dirty little secret of cellular reprogramming. The same mechanism that makes cells young is disturbingly similar to the mechanism that causes cancer. Remember those Yamanaka factors I mentioned? One of them is a gene called c-MYC. c-MYC is a known oncogene. That means it has the potential to cause tumors. When you turn a cell all the way back to a stem cell, it loses its identity. It starts dividing rapidly and uncontrollably. If you do this in a living animal without careful control, you don't get a youthful animal. You get a ball of tumors known as a teratoma. These are horrific growths that can contain teeth, hair, and bone. It is the stuff of nightmares. This is why scientists are terrified of using the full cocktail of factors in humans. Always keep in mind that an immortal cell is often just a cancer cell in disguise. The challenge is to find the Goldilocks zone. We need to reprogram the cell enough to make it young, but not so much that it forgets what it is. We want a younger skin cell, not a confused stem cell that decides to become a tumor. This is called partial reprogramming. Instead of holding the reset button down until the computer wipes the hard drive, we just tap it briefly to clear the cache. Current trials are excluding the dangerous c-MYC gene to reduce this risk. But we are venturing into unknown territory. We don't know the long-term effects of resetting our biological clock. Could it trigger dormant cancers years down the line? Could it cause our organs to fail in unexpected ways? We simply don't have the data yet. And while we wait for those answers, some researchers are looking in much stranger places for solutions. Places that sound less like a medical lab and more like a horror movie. If the genetic engineering route scares you, the alternatives might not make you feel any better. Let's talk about the modern version of vampirism. It is called parabiosis. Years ago, scientists stitched two mice together, one old, one young. They shared a circulatory system. The results were shocking. The old mouse got younger. Its fur became shiny, its muscles stronger. The young mouse, unfortunately, aged rapidly. This confirmed that there are factors in young blood that can rejuvenate old tissue. This has led to a gray market industry of plasma transfusions from young donors. It sounds ghoulish, but the science behind it is surprisingly robust.
Then there are the animals that defy the rules. Take the naked mole rat. It is an ugly, hairless rodent that lives underground.
Imagine a world where death is optional. Now imagine the price tag on that option. The first generation of these therapies will not be cheap. We are talking about personalized gene therapies and AI-designed proteins. These could cost millions of dollars per treatment. This creates a terrifying scenario. We risk creating a biological caste system. Throughout history, the rich have always had better lives. They had better food, better houses, and better doctors. But ultimately, they died just like everyone else. Death was the great equalizer. A billionaire couldn't buy his way out of the grave. But what happens when that changes? What happens when the wealthy aren't just richer, but biologically superior? Imagine a ruling class that never ages. They never get frail. Their brains never decline. And most importantly, they never retire. This is the gerontocracy risk. If the most powerful people in the world can live for 150 years, how does the next generation ever rise up? Innovation often comes from the young challenging the old. If the old never leave, society could stagnate. We could end up frozen in time, ruled by an immortal elite that has hoarded all the resources and wisdom. Economic modeling suggests that extending healthy life could add trillions to the global economy. It makes sense on paper. Healthy people work longer and spend more. But the distribution of those gains is the real issue. Will these treatments eventually become as cheap as antibiotics, or will they remain a luxury good reserved for the top 1%? History suggests that technology eventually becomes cheaper, but the transition period could be brutal. We might see a century where the divide between the mortals and the amortals tears society apart. It is a heavy price to pay for the fountain of youth.
So, where does this leave us? We are living through a unique window in time. For the first time in history, our computing power has surpassed our biological complexity. We are no longer just observers of our own biology, we are becoming its engineers. The convergence of AI and gene therapy suggests that aging is not a law of physics, it is an engineering problem. And engineering problems have solutions. The first person to live to be 150 has likely already been born. They might even be watching this video right now. We are moving toward longevity escape velocity, the point where science adds more than a year of life for every year that passes. If we can hang on long enough to catch that wave, the future of humanity looks radically different. But we have to ask ourselves if we are ready for that future. We are the last generation to accept death as inevitable, or the first generation to decide who deserves to live forever. It is exciting, it is terrifying, and it is happening faster than you think. What do you think? If you had the chance to reset your biological clock, would you take the risk, knowing what we know now? Let me know in the comments below.